Hello, my name's Kevin Burgess, and I've been teaching organic chemistry to undergraduates and graduate students for ever. Today I'm going to talk about fragments and functional groups. This is related to nomenclature. One of the things I dislike about sophomore organic chemistry is students get really hung up about nomenclature. Should I number from this end? Should I number from that end? Is it alphabetical in this case? What comes first? What comes second? Students come to me with molecules that are more and more complicated, and even I don't know the right answer. Honestly, I don't really care, because I don't think it really matters anymore. What is clearer, this or this diagram? So these days, when it's so easy to draw structures, why don't we just draw them and illustrate what we mean? That's what I think. Far more important to sophomore organic chemistry and a student doing well in the course is a functional group. And the unfortunate thing is, a professor like me will flash up a table of functional groups, and it gets longer. And then they'll say to the class, learn these, or you should remember these. And of course, there's no one in the class who's going to go away and learn all these functional groups from that table. It's too boring. And many syllabi are organized by functional groups. Reactions of alkenes, reactions of alkynes. If a student doesn't understand, they can't really organize the subject for themselves. Let's say you began sophomore organic chemistry and you think that you know enough about functional groups already. Well, let me quiz you a little bit. Stop the video. Can you name these functional groups on the top row? And on the second row, can you draw out those functional groups from these formula and put the names below? I challenge you. Can you do it? Worse, there are so many ways to draw a given functional group. It gets really confusing for the students. I didn't realize how confusing it is until I tried a little exercise myself. So stop the video again. How many different ways, using abbreviations like the ones I just talked about in my last electronic book, can you find to draw this molecule? Are you ready? Think carefully, stop the video. I challenge you. How many ways? Can you get 5? Can you get 6? See how well you can do. Because I thought about it for a long time, and here comes the answer, lots. I was horrified by how many, and I know professors habitually draw them in different ways, and the student, if they don't understand the fragments and abbreviations, and they don't understand what the functional groups are, then very, very difficult. So overall, it's really important to learn functional group early. Can you draw in functional groups on these molecules? If you have a little bit more time, you stop the video, draw the molecules out again. It's good practice, and then feed in the functional groups. Can you get them right? If you can't, you need problem. You probably understand what, say, an ether or an ester is, but what you can't do is, when challenged, draw an ether or an ester into a molecule and get it right. You need to practice this over and over again. And that's why I wrote my little workbook of problems, a workbook with an attitude. It's available on Apple Books. It costs you about half a cup of coffee. The answers are online. This is one of a series from byinquisition Press, and that series is getting longer every week at the moment. So this is you. Most of my students look pretty similar to this, actually. And that's your tablet, the tablet of your choice. You download the book, and what I want you to do is work through all the problems one by one. You can refer to a text, but you can't refer to my answers online. You can do detective work. You can look in Wikipedia or Google or whatever, but don't look at my answers online. And write in what you think is the correct answer. And then I'd like you to check your answers online. And any that you got wrong, delete. The next day, not immediately, it has to be the next day, try to feed in those answers for the blank, the ones you couldn't get right. Why does it have to be the next day? Well, because when you see things and hear things, and you're thinking about a little bit, they go into your short-term memory. But at night, your brain undergoes night cleaning, and it flushes out all these irrelevant responses that it picked up during the day and doesn't think are that important. Probably because you didn't think of, say, an organic chemistry lecture at all after you left the lecture room. And so the next day, you'll forget. But if you try to recall, then you find that the forgetting curve works for you. You find you remember a little bit more. And then you erase blanks again and go back over it and try to recall again. And you'll remember a little bit more. It's hard, it's difficult, because thinking about organic chemistry is not everybody's favorite thing. It's a form of torture. You have to force your brain to do it. If you do, you learn. But if you cheat and you look at my answers online too soon, then the torture must begin again. Thank you very much for listening. Bye-bye.